Hello everybody, this is Dr. Hussein. Um, in Introduction to Digital Systems. Now, today's topic is circuit analysis procedure, okay, where it is linked to the course learning outcome about construct and analyze various representation of logic functions and perform conversion between them. Now, and the general overview of this topic is analyze digital circuit. How we can analyze digital circuit? Giving the circuit, we need to create truth table or to create and minimize circuit. We will test and discuss here two approaches. One of them is Boolean expression approach, and the second one is truth table approach. We will see how we minimize toward implementing in hardware. And next topic, we are going to link what we discussed now with the Carnot map, how we use it to simplify and go to the hardware. Now the problem. What is the problem, or our problem we are going to discuss in this topic? How we can convert circuit, logic circuit drawing into an equation or truth table. As example, you are given here a circuit, logic circuit, okay, drawing, and you have ANDs, you have ORs, you need many inputs and one output, sometimes intermediate outputs. Okay. Now there are two approaches. The first approach is create intermediate equation, and the second one create intermediate truth table. Let me start with the first one. Now this is my logic gate. The first issue is I started from the input. As you can see here, these are my inputs, ABC, and this is C dash. Okay. I start labeling, okay, the output of these gates related to the input. As example, the output of this AND gate, I call it R. Here, I call it S for OR gate. And for this AND gate is T. I start, as I mentioned, from the input toward the output. Then I start finding the equation representing R, S, and T. And then this represents the intermediate, right? Then I move to the output. I will show you the steps. Have a look. This R is the output of this AND gate, right? Which means that it's multiplication. A, B, R equal A, B, C. That done. Easy? Okay. Now this S is output of OR gate. You can see here A, B, C, A, B. So it's sum, add A to B. Done. And then T, which is this output of this AND gate, which represent S and C dash. So we'll see C dash S. Now the output of the whole circuit, logic circuit, is directly R plus T. Done. You see? This is the second step. Third and last step is to substitute, okay, to make the relationship for the output in terms of all inputs. How? Have a look here. We say it is R plus T, which is the output. But just a minute. R is this part. You see? I substituted. And T is this part, but which is at the end is this part, because I need to substitute for S. And this part is S. You see? So how it look like the output now? It look like in terms of A, B, C, and C dash. These are my inputs, as you can see here. So don't forget, we started from logic gate circuits and we moved toward the expression or the equation. Now, when we put it in this way, we need to simplify more to make it sum of product. You may ask, okay, why sum of product? You remember we discussed in the previous topics how we use NAND gate, one NAND gate, I mean just one gate, which is NAND gate, to represent sum of product, which make our work more easy. You depend on one gate, okay? So I converted into NAND gate because you need to use the distribution property. You need C dash multiply here and here. So what we have here, this is AND gate, this is AND gate, and this is another AND gate, and all of them connected through this OR gate. You see, I started in the first approach from the logic circuit diagram, then I moved to the expression or the equation. Now, approach number 2 is to use the truth table. I will not define here the, let me say, the expression or the equation. I just need to name the output of each logic gate. As example here, R. R is output of this AND gate, and we know AND gate is multiplication. A, B, C. It means it should all of them be ones, so we have output 1. This is that, as you can see here in the truth table. And here only we have 1 because all of them are 1. Now for this gate, which is OR gate, the output is S, which depend on A and B. And since it is OR gate, then any one of them 1 will give 1. You see here, this is 1. You see here, this is 1. Also here, this is 1. Here, this is 1. And last two, 1. You see, whenever we have 1. Now I found S. Now I have RS, I add T here, okay, and I start completing to find T. I have T, I have R, then I add here, okay, to say this is my output. You see? So this, we take them gate by gate to find the truth table until we reach the output. You see here, I added T because it's multiplication of R and R and T. I added the output. This is T, which is the T is the multiplication of S and C dash, and then I have the output. Just follow them. You will find it's very easy. But this is easy when it is small circuit diagram. I mean, the logic gate is small. What about the large one? It will be more complicated to use truth table. Truth table will be more complicated. Example is this. You can see here this is more difficult because we have many ONs, many ORs, gates, but still the principle is the same. We take them by one by one. As example, I can take these two together. Let me say here I will put R, output is R1, and here output is R2, and here output is R3. It's very easy, I mean, this way. And then I name here the output, and then also the output here it's already named, the output here is already named, okay, and this is inverse, so I can find T3, which is already named, F dash, which is the opposite of this. This means this is F, okay, F2. Oh yeah, it's already named here, sorry, it's already named here. And this is the final. So take them one by one. Here is the truth table, okay. You see I put A, B, C, then 5 phase F2, and then the inverse of F2, and then you move T1, T2, T3 until you find the last F1. I advise you to check them one by one. As I mentioned always, here we need to practice, solve more problems, practice more. So this will give you the experience to solve these type of problems. Now here exercises, we will work together in this exercise. Have a look at this exercise. First one is, he asked me to create intermediate equations, logic function, and truth table. Now if I come here, I will say this is inverse B, B inverse, as you can see here, and the output is B dash C dash, and this is A, this is OR, then I will say X equal A plus B dash C. Now I come to the truth table, okay, I put it here in this way. You will find here A, B, C, okay. It's better to put B dash, okay. Oh, okay, B, here let me put dash, B dash. Doesn't matter if we have more columns. And then here B, C, you see, B, C, B dash C, sorry, and so on. You add more, and you started here listing the options. You have 3 outputs, so 8 options, okay? And then you check the truth table as we learn. And this way you solve, because always I advise you to read the question carefully and try to fulfill what the requirements, what he wants you to do. As example here, he say create intermediate equations, I got it here. This is the intermediate equation for this one, and this is for this one, and here is the output. You wrote it. Also, he say and the truth table. You need to implement the truth table here. So try to follow it. It's easy. Now the second one is create a logic diagram. Okay, he want me to do logic diagram with gates and truth table. Truth table I leave it to you, but logic diagram how we execute it. Have a look here. What we have? We have C A plus B dash C. You can directly say I will plot here A plus B dash. This is represent OR gate. You see, OR gate in this way. This is A B dash, as you can see here, and the output with A. This is A. Sorry, with C. Sorry, with C represent the output of AND gate. This is the output. Give me X. Or you may say, oh, let me use distributed property of a Boolean expression, and then it will be equal to A C plus B dash C. So you see here, or with two inputs in this way. We can see, you can see here, two and this is and one, and this is and two, and they are input to OR gate. As you can see here, this is X, and this AC is the input is here, output here, because here A and C, and this B dash C is the output here, where B and dash and C is the input for this AND gate. You see? After that, you need to implement the create the truth table, and I think it's easy. Now we are familiar with creating a truth table. Now, the last one I will leave it to you as exercise. Please start to work on it. He told you that fulfill the truth table of the function. He gave you here the function, as you can see. I will give you a hint, and then you start working at home on this. He gave you here A, B, C, A dash, B dash, C dash. He asked you to find the final X. Okay, I will come to say that AB, I will put here A, as you can see, B. It's AND gate, and you know all of them should be ones to have one for AB. It means, where is it? AB here, 1. Okay, here also is given 1. Okay, so you can see here 1, 1, and all others from here to here are zeros. Then plus C, you will say here it is A, B plus C dash. You got it. You have AB, you have C dash. You check how to, any one of them is 1, will give 1 because this is OR gate. Now you come to AC, you write here A plus C, OR gate. Also, any one of them will be 1, the output will be 1. And then you come here to the X, because you have the first bracket and the second bracket in AND gate. So both of them should be 1 to have output 1. You see, you distribute the work, start to work on it at home, and to find the truth table. Now, to summarize this discussion, this is, let me say, this topic, let me say, initiate the discussion for the next topic, because next topic will use Karnaugh map. Now, here we discuss how important, if we are given the block diagram, logic gate circuit block diagram, and how we can find the expression, or how we can find the other way is to find the truth table directly. Okay, these are the two approach. This will be minimized when we next topic we will discuss this, how to minimize using Karnaugh map. Let me stop here. More examples available in the textbooks, which is Digital Fundamental by Thomas Floyd, and also many examples available online. Just Google them, you will find many solved examples. Thank you and see you later.